Reference is like a pointer that is ensured to be address of a type's valid value for life of it. Share references ampersand to create a reference for an entity, asterisk to dereference. So let's do some sample code for it. We'll create a variable for char called a and reference it via an r. So r should borrow the address value from a. Now let's try run it and see. Changing value to borrowed entity in the life of use of its reference would raise an error. So if we do this, it should cause an error. Let's check that as well. Deref isn't always required. As you see, we are simply using R. This should work fine because it's outside the life of the borrowed R. And even if we do asterisk R, that will be same with explicit dereferencing. So Rust recognizes the life of borrow and allows alterations out of its range primarily. Now let's see if dangling references are allowed or not. As you see, we are getting an error here for the same. Now let's move ahead, clean it up. Shared references are called borrowing. They are read-only links to the data, and as you've seen, ampersand is always required. Mutable shared references just means it can borrow from another entity, not change the value. So now we'll do some sample code for mutable shared ref. Let's create another variable and we'll have our reference as mutable, so that would mean that we can change what value is being borrowed. Now let's just try it out. Works fine. Next, on to exclusive references. These are mutable references as to be able to change value they refer to, not just to change the value they are referring to. So if it's doing an ampersand mutable entity name, that means it can go ahead and change the value that is assigned to the variable it is referencing to. So here EXR should be able to change the value that's assigned to A itself. Here asterisk EXR is required. So error for using variable while the mutable borrow is in action would cause an error as well. Only one exclusive reference at a time is allowed though. Now to slices, slices are created borrowing a collection with new start and end indexes. If start index is still 0, it can be skipped. If end index is same as of collections, that can be skipped. For memory safety, the borrowed reference rules apply. Now let's test out how it safeguards by changing order of usage in this online sample itself. As you see, it causes error while changing the borrowed entity within the lifetime of it, and should not when done outside of it. Let's write our own sample now. let's have a mutable collection, can be non-mutable as well, just that when we create a slice here S, we don't need to specify the size in the definition of it, but when we mention that it's 2.5, it can by itself assume the size that it need to of the view that it has in the collection. 5 dot dot means from 5 to the end of the collection, and dot dot 3 means from start of the collection to 3, and just dot dot means the entire collection scope would be taken. Now let's just print them and have a look. As you see, it's a desired output. Let's move ahead. We have strings, and str is slice borrowed from valid U8 sequences. String type is stored as vector of bytes, always a valid UTF-8. Is a heap allocated and growable but not null terminated. Let's test our variations in code. So we'll start with the main. Let's have an ampersand str variable called name. We can directly assign it a string here like this. Let's print it out to check. First run, it works as intended. Now let's move ahead. We'll try out the string type. So let's call it a mutable my name, as we can grow it and change it later on. So we can do string : new and then use push to primarily add more content to it, or we can simply do string : from and just provide a existing string to it as a value. With push we can only push characters. So what this will do is, this is primarily looping around the characters available in name variable and pushing them one by one in my name. Now for variable your name, we will create from string.from, we assign on, and then we'll push the second word using push string. So push tr do, push str do, increase the same string. Working as intended. Now let's work a bit with the vector of characters. Doing chars gives you a collection of chars in the string. Collect will primarily provide you that as an array. If we do a sort on it, it will sort it within that string, within that array itself. So we'll have to run it externally, because when we run it within println, it was primarily running unit type for the run statement itself. As you see, we are getting a sorted collection. And now if we do dedupe, it will deduplicate the elements in it. Now that we are done with a bit on strings and characters, let's try replace. We'll replace a part of string. So instead of John, it will be Jack. It's working as intended. As you see, there are examples. So for the exercise, we have geometry exercise. It's primarily looks like a sample where slices are being passed onto functions which need to be implemented. Let's copy the function code to a separate file and implement it. So it has magnitude, normalize. Let's look into main. Magnitude is getting passed slice, and then a mutable collection is being passed to normalize, which seems to be working on the collection itself, and then that change gets reflected automatically. And the magnitude is actually returning a value separately. So since the signature is float with 3 length, that's what we have mentioned in the definition. Now let's implement it. We already have the formula to implement it in the comment up. So let's pull it down. So it says it calculates the magnitude of vector by summing the squares of its coordinates. So for sum, we'll create a mutable variable with 0 to start with, and then on each iteration for the coordinates, it will sum into itself the square of it. And the comment says there is an sqrt method that can be called on the sum, so we'll call it. And since we don't have any semicolon at the end of it, the value will get returned. Now let's implement normalize. It says normalize a vector, and it is being passed a mutable vector. So let's have the signature accordingly. Here the calculation is first to get the magnitude, so let's fetch the magnitude, or let's have a different variable name since we already have the function name by magnitude. So let mag is equal to magnitude, we'll pass it the vector itself, and then dividing all of its coordinates by that magnitude. So we'll again loop over the vector that's being passed and modify the vector itself, so all of them are divided by the magnitude, and we don't need to return here anything since it will be reflected here. Let's run it and see. Seems to be working fine. Shouldn't have the warning as well. Okay, now let's move on to the solution that's online. Looks similar to what we implemented. Now let's run it and check our values. Our values are 92361 107832. Yep, the values match as well. Okay,